Hello and welcome to the next video of Python Bytes problem solving. In this video, we will see how to calculate the longest consecutive run of ones in a binary representation of an integer. In this problem, we have been given an integer n and we have to count the number of ones that are there consecutively in its binary representation. So we have been given an integer n and we have to convert it into its binary form. So to convert the integer into binary form, Python has its inbuilt function bin, and if we give n, we get its binary form in a string format. So it's in binary form. So for example, if bin 4, the output will be 0b100. So Python adds the first two characters to the string, that is 0 and b, to represent that it is a binary representation of an integer. So now that we have understood how to convert an integer to binary, let us see in the next part that how to count the consecutive ones. So for example, let us start with an example 0b1011001111. So if you see this binary representation, we have to count the maximum number of times 1 is there in consecutive way. So we will start a for loop to go from each bit in binary number. So binary number, we will start a for loop. So we'll traverse through all the characters in the string. So once you start traversing or iterating through each of these characters, we have certain condition. If the bit is equal to 1, what we do is we increase the counter. So what is counter? So we are going to have two variables and they are both going to be counters. So one is going to be count and one is going to be max count. So whenever we encounter a bit 1, we are going to increase its value by 1. And we will also check that if max count is less than the count that we have done here, we will change the value of max count to count. What happens if bit is 0? What we do is we reset the count to 0. So we reset the counter. So now in this example, if we traverse from, so I'll write all the example over here so I can explain it much better. So we started with 1, our count was 1 and our max count also was 1. Now when we encountered 0, we reset the counter to 0. Again in the third position there was a 1, so our counter became 1, but we already have max equal to 1. In the fourth position the counter became 2 and our max, when it reached fourth position, our counter became 2 and our max was updated to 2 because initially it was 1. Now we reached fifth position, it is 0, so the counter is 0, max value doesn't change. In the sixth position also the counter is 0, max value doesn't change. In the seventh position we get counter 1, eighth position counter 2, ninth position we get counter 3. So in the ninth position, when we go in the ninth iteration of the for loop, we have counter 3 and our max is converted to 3, is updated to 3. And in the 10th count, our count is become 4, so our max is updated to 4, and that is the end of it. So we will return max as 4 over here. In the similar example, if the value was 0110100, so this was the value. So the max value is encountered over here. So even if we encountered a 1 over here, our max was already stored to 2 and the max will be returned to 2. Now let us see this how we implement in the code format. Let us start coding the problem. So here we are given an integer n and we have to return the length of longest consecutive run of ones in its binary representation. So we are going to use a function called consecutive ones binary, and it has one argument num, and we have pre-declared it as it has to be an integer format. So the type of num is going to be integer. So we will start with converting this num into binary format. So we are going to name the binary representation as bin num, and we are going to use Python's built-in function called bin, and the input is num. And if we print bin num, let us remove this pass because we are going to use this function, and let us make this input 156 because we have given an example 156 and it should return 3. So now if we run, we get output as B01001110. So we can see over here there are 3 consecutive ones and our program should return that over here. So let us create our 2 counters that we had seen in our discussion. So count 0 and max count is also 0, and we are going to return max count in this from this function. So now let us start iterating through the bin num. So bin num, as you see, is a string. The output is going to be string, so we can iterate through the string, and every iteration will be a character. So bin num, and now we are going to apply our first conditional if condition, and that is if the bit is equal to 1. So 1 is not number or integer, it is a character string. So if bit is equal to 1, we increase our count by 1, and we'll check, we have one more check to do. If the max count is less than the count, we will increase the max count to count, and this way we will get the max number of counts. But if we run this now, we will get our output as 4. Why? Because when the for loop was running, it encountered the first one over here, and the counter became 1. Max count was 0 then, and when the count was 1, it incremented max count to 1. But second time it came across 0, it did nothing in this if loop. It didn't ever enter the if loop. Now when it encountered the second one, it added the counter to 2. But that is not our aim of the function, right? Our function is to find consecutive ones. So as soon as we encountered 0, we have to reset the counter to 0. So else, so it is either 0 or 1. So if it is not 1, then we will reset the count to 0. And now if we run this function, we have given input as 56, 156, and now we have output as 3. So let us now check 15 and let us run it, and we get 4, because 15 in binary format is written as 4 ones, 1 1 1 1, and all those are consecutive, so it is 4. Let us make it 23 to see one more example, and we get the output as 3, even if there are 4 ones, but there are only consecutive 3 ones in it. Thank you for watching this video. I hope you understood how to calculate the consecutive ones in a binary representation of an integer. Please like this video and subscribe to the channel. Goodbye till next time. Keep coding.